Okay, so this will probably be the last video because I think I can fit everything into this video. And what I forgot to mention from the first video, in that last example where we had, let me go back, where we did the first one together, so this should go when you had 7x plus 5. So this is from the last video. So we simplify, and this was f plus g of x. You also have to write the domain. So remember, when you turn this in via email on Moodle, make sure you also write the domain for each of those functions. And so for this one, the domain, since it's a polynomial, it's just going to be all reals. Okay, so I forgot to mention that in the last video. Now, for the composition of two functions, this is just another way to look at how to combine functions. So far, this is what we know, that a function is this machine, right? So we take an input, and I'm going to make my little machine. Let's call that f. I name my function f. So I input x, and I get out f of x. Okay. And then let's say now I have, so I'll choose another color. I have another machine, and let's call that machine g. And so now when x goes into g, out comes g of x. Okay. Now, what if I combine these two functions? So that means this. So I'm going to spread it out a little bit. So I have my function f, and I input that. I put input x into f, and like we said earlier, we get out f of x. But then I take that f of x, and I put that value into my g function. So now my inputs are f of x, and my outputs will be g of f of x. And that's basically how the composite function works. And you can do it the other way as well. And if we did it the other way, then we would have had f of g of x. Okay. So this machine combining the two functions, this is called the composition of g with f. And you might see it denoted as f circle g, but that's just saying g of f of x. So those two are the same thing. And just to note here that this is your inner function. So this function gets applied first. Okay. So let's look at an example together. So we're going to, for this one, we're going to find f of g of x and g of f of x. We're going to do f of g of x together, and then g of f of x is going to be left for you to turn in for your quiz. So f of g of x, well, what does that mean? In this case, g of x is our inner function, and g of x, by substitution, g of x is equal to x squared, So we can replace g of x for x squared. So this equals f of x squared, and now we are just using our f function, and this is saying wherever you see x in your f function, so that's our f function, we plug in x squared. So this is going to equal 2, and that's just the same as square root, so I didn't even have to put that 2 there. X squared plus 5. And you can't simplify that any further. You can't take anything out or split anything apart, so that's your final answer. So this is, so for your video quiz, this is number 2. Your first problem was given on the first video. I want you to find g of f of x. Okay. Now, 3a, it says f of x equals x squared plus 2 and g of x equals 1 over x squared. So we're going to find g of f of 11 and f of g of 11. And I wrote it in these, remember the notation, this represents the same, the notation in terms of the circle represents the same, but these are two different problems. I wanted to write it two different ways because you might see it in either way in your book. And we're going to do the first one together, and then I'm going to leave the second one for you to do on the quiz. So g of f of 11 is the same thing as just saying g of f of 11. So first, let's figure out what f of 11 is. Well, f of 11 is, so we're using our f function, is 11 squared plus 2. So that's 121 plus 2, so that's 123. Now we take g of that value. So g of 123, our g function is given here. So that's going to be 1 over 123 plus 1, which is 1/124. Okay, so question 3 would be find f of g of 11. Okay, so figure that one out. And I just want to make sure this is the end. Oh yeah, so this is, actually I think I might have one other problem, but I'll probably have you do that one for your quiz. So I wanted to talk about decomposing a function. We won't go into too much detail with this, and we won't do a lot of problems with this, but I want you to see it because it may be useful in the future. So what decomposing a function means is to break it down into two other functions. So composition of functions is taking two functions and combining them together. Decomposing is taking one function and breaking it up into two functions. Two or more, but we're just worrying about two functions. So here's an example. Let h of x equal 1 over x minus 2 squared. All right. Now we need to rewrite h of x as a function, as a composition of two functions. And basically what that means is, how can you represent that expression in two functions? Okay, so what's going on here? And there's different ways to do this. And I'm going to show you one way, and then I want you to try to do another way to decompose a function, this function. Okay, so let f of x equal, you basically look and see, okay, what's going on with this function? Well, we have a linear expression, that x minus 2 in there, and then we also have this exponent right here. So we need to figure out, well, how can we decompose those two things? Well, first, what I decided to do is let one of my functions equal that inner expression, x minus 2. And then I'm going to let, so what's left over? Well, if I've already let one of my functions equals x minus 2, then that exponent is just left there. So that's 1 over x squared is what's left. And so what this is saying is, if I had g of f of x, this will equal, given what we just created, g of x minus 2, and g of x minus 2 is going to equal 1 over x minus 2 squared. So this is, we just created that function h of x by taking two functions. And so what I want you to do, this was, I found g of f of x. I want you to find two functions that when you do f of g of x, you'll get h of x. And this will be question 4. So that's going to be, it's just 4 questions that you need to answer for your quiz. So I'll give you more instructions, but basically you're going to answer them on a sheet of paper, and you can either take a picture of the paper or put it in a Word document or a PDF, and you're going to upload it on Moodle. I'll leave a tab open. I'll have a tab open so you can upload them on Moodle by Friday, by noon on Friday. Okay.